Hello there, I am Imitalkush. In this video, we will solve one problem in chapter 5. A block of mass 5 kilograms slides down with constant velocity on a frictionless surface with the help of a force of magnitude 20 newtons directed upward along the surface. A. Draw the free body diagram of the block. First of all, we choose the natural coordinate axis. Next, we represent mass by a big dot. As you notice, the mass sits at the origin of the coordinate system. After that, draw only forces on the body. The first one is the gravitational force on the body. Now it is suitable to decompose this force into x and y components as the following. As you see, we write only the magnitudes of these components and it is not necessary to use vector form here. Secondly, since the mass is in contact with the surface, so the normal force is drawn perpendicular to the surface like this. Finally, the external force F is drawn upward along the x-axis. As the final step of drawing the free body diagram, we draw acceleration vector separately from the body. Here, since the block has a constant velocity, we say that it has a zero acceleration. Okay, that's all about the free body diagram. B. What is the angle of inclination of the surface? First, we write the equations of motion. By means of the Newton's second law, that is, F net equals ma, equation of motion along the x-axis become F minus m times g times sine theta equals 0, since the acceleration along the x-axis is 0. From this, we get an expression for theta. With the numerical values, we obtain 24.090 degrees, which is approximately 24.1 degrees in three significant figures. C. What is the magnitude of the normal force acting on the block? Now we write the equation of motion along the y-axis. Since there is no motion along this axis, we write n minus m times g times cosine theta, which is the net force along the y-axis, is equal to 0. Therefore, n becomes m times g times cosine theta. If we insert the numerical values into this equation, we obtain approximately 44.7 newtons. D. If the angle of inclination was set to theta equal to 5 degrees, what would be the magnitude and direction of the acceleration of the block? Here, since 5 degrees is less than 24.1 degrees, the block will accelerate upward. Then we can draw the acceleration vector separately from the body as follows. Now we write the equation of motion using the Newton's second law along the x-axis. If we choose the direction of the acceleration vector to be positive, then the net force along the x-axis becomes F minus m times g times sine theta, which is equal to m times a. From this equation, we get an expression for acceleration as F over m minus g times sine theta. Now, put the numerical values into this equation, then we get approximately 3.15 meters per second squared. Okay, as you see, the block speeds upward along the surface. Alright, that's all about this problem. Thank you for your attention. See you in the next video.